we can have a look at the different Kubernetes resources across the different clusters we're monitoring. I am selecting Kubernetes nodes, which gives me a consolidated view of the different Kubernetes nodes across the clusters, and I can pick up one that is used for development. From a resource consumption perspective, I can drill down into the single pods and containers within those pods to have a view on the CPU and memory allocation to each of those resources. If I want to look at things from a different angle, from an application angle, I can select a specific collection of resources within the same application. For example, the stock trader application exposes a number of services, and I can pick the one I'm interested in, the trader service. When selecting a service, the monitoring dashboard displays the 4 golden signals of the site reliability engineering discipline: latency and errors, which are typically related to symptoms, and traffic and saturation, which are most likely bound to causes that generate those symptoms. This particular service is made up by 3 pods, and I can also go back in time to this morning to observe when an event had occurred. In particular, this event corresponded to a new deployment, which had some ripple effects on the 4 golden signals. We can see a spike in both traffic and saturation, which, as we said, are typically related to causes. I want to go and investigate those causes. The service dependency map helps me in this investigation. I can see that the trader service has got a direct dependency to the portfolio service. By clicking on it, I can have more information on the portfolio service. Also, the portfolio service had a new deployment this morning, which caused some effects onto the golden signals. We can see that latency hasn't gone up immediately. However, both traffic and saturation start to spike corresponding to the new development. This could be related to thread pool saturation, as well as new Java code that was introduced by the web developer, which has caused some issues down the line. This suggests that there is a saturation problem with the service. I can also observe the dependency map for the portfolio service and realize from here that although this service is dependent on 4 components, the health status of all those 4 components is good. So most likely the problem is with my portfolio service itself. At this point, I've got 2 courses of action. I could go back to the original code which didn't cause the issue, or I could decide that I want to keep that code, but I want to mitigate or solve the issue with this existing code stream. I choose the latter and scale the number of pods in the portfolio service so that the saturation could go down, at least temporarily. After having scaled out portfolio service, traffic and saturation, the 2 golden signals related to the causes of the issue we've identified, drop down immediately. Although this action might have not solved the issue in the long term, at least I've been able to mitigate it in the short term. Let's see what is the effect of this change on the trader service, the one that displayed a problem in the first place. As soon as that change was made in portfolio service, which reduced traffic and saturation, the latency of my trader service has gone down completely, which means that I've solved the issue that had caused this latency problem in the first place.